Okay, 2.3, solving inequalities using multiplication or division. So when we're multiplying or dividing both sides of an inequality by a positive number, then an equivalent inequality is produced. Okay, so when I'm solving this, I'm trying to get x isolated. So right now x is divided by 2, so the opposite of dividing by 2 would be multiplying by 2. So I'm going to multiply both sides by 2 here. Those will cancel, and then I have x is less than 8. So this is my solution, and then I just graph this on the number line. So since the inequality symbol isn't underlined, that means I have an open dot above the 8, and it says x is less than 8. I want all the numbers less than 8. Those would all be over here. Okay. All right, next one. T is divided by 5 here, so the opposite of dividing by 5 would be multiplying multiplying both sides by 5. So those will cancel there. T divided by 5 times 5 is just t. Okay, and then negative 2 times 5 would be negative 10. Here's my solution. So let's graph it. This inequality symbol is underlined, so that means t can be equal to negative 10 as well. So I need a closed dot. That shows that this is part of the solution, where an open dot shows that the number 8 itself on this one is not part of the solution. Okay, and then I want numbers more than negative 10. Those be over here, this direction on the number line. Okay. Let's try a couple more quick ones here. So here I've got 3 times m. I want to isolate the m. So here I want to do the opposite of multiplying by 3, dividing by 3. Okay, and now I've got 7 is less than or equal to m. Okay, I like to flip around my inequality so that the variable is on the left-hand side. I think it just makes it easier to graph. So I'm going to put the m here and the 7 here, and then if you think about, okay, the alligator eats the bigger number, so the alligator's eating the m. I still want the alligator eating the m here, so that means that inequality symbol is flipped around. Okay. So then when I'm graphing this above the 7, I have a closed dot because this is underlined. And now you can just follow the arrow directions. This arrow is pointing to the right, so that's going to go to the right too because I want numbers greater or equal to 7. Well, all those numbers are over here. So when you flip around it so the variable's on the left, you can use the same directions. You see the arrows pointing to the left, the arrow there goes to the left, arrows pointing to the right, arrow goes to the right, and so forth. Okay. All right, so this next one I want to do the opposite of multiplying by 6. So I'm going to divide by 6. That will isolate the r. Negative 18 divided by 6. A negative divided by a positive would come out negative. So this is negative 3 is greater than r. And I'm going to flip this around, and when I flip it, I have to flip the symbol as well. So I want the alligators eating the negative 3. I want that to still be the case. There's my solution. Okay, got an open dot above the negative 3, and I need numbers less than negative 3, so there they are. Okay. All right, let's try some more on the next page. So sometimes you might have to multiply or divide by a negative number in order to isolate a variable. See, this is divided by negative 3. This one's also divided by negative 3. So on both of these, I'm multiplying or dividing both sides of an inequality by a negative number. Okay, and you can still get an equivalent inequality, but you must if you reverse the inequality symbol. So that is important. So when you multiply or divide by a negative number, you're going to have to flip the inequality symbol. Okay, so here I'm going to multiply both sides by negative 3. Okay, and that means that this symbol is going to get reversed. So it's pointing to the left. So I'm going to reverse it like that. Okay, those negative 3's cancel. Got x, and negative 2 times negative 3 would be positive 6. So there's my solution. It's really easy to forget to flip the inequality symbol, but you must do that when you're multiplying or dividing by a negative number. So open dot above the 6, arrow going that way. Okay. All right. So again, I'm dividing here by negative 3, so I'm going to do the opposite and multiply this whole thing by negative 3, and I'll multiply this side by negative 3 as well. Okay. So that means that this symbol is getting flipped around. It's pointing to the right now, so let's have it point to the left, and it's still underlined. Okay. These would cancel, so I just get t over here. And then 4 times negative 3 is negative 12. Okay. And I have just enough room for that on the graph here. So let's see, I've got a closed dot here because the negative 12 is included and its numbers less than or equal to negative 12, so they'd be that direction. Okay. All right. Next problem. Here it's m times negative 4, so we want to do the opposite of multiplying by negative 4. Sometimes I see people add 4 to both sides, but that's not going to isolate the m there, right? The relationship between the m and the negative 4, they're multiplied together. So need to divide by negative 4 here. Okay, again, I'm dividing by a negative, so that means I'm flipping this around. Okay, and then let's see, I've got negative 5. 20 divided by negative 4 is negative 5. The negative 4's cancel. Okay, and then I'm going to take this whole inequality and flip it around again so that the variable is on the left. So the alligator's eating the negative 5. I want that to continue. There's my solution. Okay, so closed dot because this is underlined and its number's less than negative 5, which would be to the left of negative 5 on the number line. Okay. All right, one more of these. Here I'm going to divide by negative 7 to isolate the r. That means this flips around. So need it going that way now. Okay, 28 divided by negative 7 is negative 4. And then I'm going to flip this whole thing around so the variable's on the left. Alligator's eating the r. So there, the alligator's still eating the r. And then let's see, negative 4 with an open dot. And I want numbers great. R is a number that's greater than negative 4. That would be that direction. Okay. All right, let's try a word problem. All right, here Deagle works a summer job and earns $17 an hour. There's a typo there, an hour. I'll fix that. Okay, write and solve an inequality that represents the number of hours he needs to work to buy a rowboat that costs $544. Okay, so $17 an hour. Let's say that X is the amount of hours he's going to work, X amount of hours. Okay, so if you take 17 and multiply it by X, if he works 1 hour, it's $17. If he works 2 hours, well, then it'd be 2 times 17, which would be $34. Okay, so however many hours he works, we want that to be greater or equal to $544. So that he can afford that rowboat. It's okay for him to make more than $544, then he just has extra money for something else. Okay, so we've written an inequality. Now let's solve it. So I want to isolate the X. I can do that by dividing both sides by 17. I'm not going to flip the symbol because I'm dividing by a positive number. Okay, and then I'm just going to use a calculator to quickly do the division there. 544 divided by 17 comes out to 32. Okay, so I've solved the inequality. So write an inequality that represents the number of hours he needs to work to buy a rowboat that costs $544. So that would be 32 hours or more. Needs to work at least 32 hours is another way to say that, right? Anything more than that would work as well. Okay, that's the end of the section, and I'll see you next time.